Hi, I'm Chris from Fuzzy Labs, and we're trying to help parents restore their dignity when playing Dobble against their children. Why are we doing this? This is part of our submission to ZenML's Month of MLOps competition. This competition spans 4 weeks, and our team's spending 1 day a week working on our entry. So where do we start in this project? We want to parallelize as much of our work as possible. To do this, we need to start off with a minimum viable product. While Jupyter Notebooks are great for experimentation, in large teams with time constraints, they're not a great solution, especially as reproducibility, reliability are key when creating machine learning models. How can we introduce reliability into our machine learning models? By creating pipelines. ZenML is a great tool for creating pipelines for machine learning models. So we decided to split this project into 2 pipelines. Firstly, a data pipeline, and then a training pipeline. So in our data pipeline, we first pull our data from this tool called Label Box, which effectively we've labeled our Dobble cards. Then we want to convert it into the right format, in this case, VOC for object detection. After doing this, we want to split this data into 3 datasets: training, testing, and validation. In our data pipeline, we perform some data validation. To do this, we use deep checks. Deep checks is a great tool for validating image data, especially. It performs some statistical analysis to see if there's any outliers, mislabeled data points, or even checking if your train and test datasets are representative of each other. The final part of this pipeline pushes this data to an S3 bucket. In our training pipeline, we grab this data from the S3 bucket, then we train our model on top of MobileNet. We also perform some model validation, again using deep checks, and finally register this experiment with an experiment tracker. So the experiment tracker that we've gone with is MLflow, and ZenML provides some great integrations to easily plug in MLflow as an experiment tracker into your pipelines. Each of these pipelines are composed of discrete functions called steps. This allows the code to be more readable. These steps help us bring in software engineering principles to data science. ZenML has this concept of stacks. This allows easy integration of external libraries such as MLflow, like we were talking about before. Or if we wanted to run a training step using specialized GPUs on a cloud provider, we can do that. So after we've trained the model, uploaded it to our experiment tracker, we can look through our experiment tracker and decide which model we want to deploy. In the final block, we're going to talk about how we get our model and deploy it on the Jetson Nano edge device. Thank you for watching.